Okay, here's another example. Okay, so what have we got now? There's the picture. You can definitely see that there's midpoint theorem happening here, even before we read the question. I mean, those are in half and those are in half, which makes these two lines parallel. Agreed? You must, if we need it, you have to write it. And then, guys, if you turn this thing on its side, you've got these, that equal, and then these two equal, right? So that makes this line here parallel to this line here. Isn't that true? And then you can even turn it on its side again. And look at these two lines here. They are also parallel because of midpoint theorem. Let me just do that second line a bit better. You see, because these, that's equal to that, and that one's equal to that one, that makes this line here parallel to this line here. Does it not? Check all the midpoint theorems happening here. 3 different ones, depending how you turn this triangle around. Alright, so what they want now is they want you to prove that triangle DEF, okay, that's this one, DEF is congruent to ADE. So this triangle in here and this triangle here, we're going to prove them congruent. Well, it's too easy because now with all these parallel sides, which we got from midpoint theorem, okay, we can get lots of things equal. Do you agree with this? Look with this side here and this side here. Do you see this Z here? See that Z? That makes this angle here equal to this angle here. I've put a little 1 in there and a little 1 in there. Okay, so let's do this. Okay, you can't just start straight away and tell me that that E1 equals D1 alternate angles. You have to first tell me how we knew that the lines were parallel. Isn't that true? So we knew those lines were parallel because of midpoint theorem. So I'm going to write here, EF is parallel to DA, midpoint theorem. Agreed? Okay. Therefore, E1 is equal to D1. Alt angles. EF parallel to DA, let's say. Awesome. And guys, the exact same thing here. I'll do it in yellow. Do you see this here? There. That makes this angle here equal to that angle there. Let's just call that 2 and 2. They are also equal because of alternate angles because of those parallel lines. So the first thing you have to write is the fact that DF is parallel to AC. DF is parallel to AC because of midpoint theorem. Okay, therefore, D2 is equal to E2. Alt angles. DF parallel to AE. Alright, DE is equal to DE, it's common. So that's SOA. Therefore, triangle, what are these two triangles? triangle DF is congruent to triangle ABE. And the reason is SAA. Okay, brilliant. Sorted out. We've got the congruency. And now they want us to prove that DEFB is a parallelogram. Let me do this DEFB in a different color. What color can I do it in? I'll just do it in blue. DEFB. This thing here. Prove that it's a parallelogram. I'm going to say it again for the millionth time because, yeah, you must know this, guys. How do you prove equations apart? Either we've got two pairs of opposite sides equal, or two pairs of opposite sides parallel, or one pair of opposite sides equal and parallel, or the diagonals bisect, or opposite angles equal. So which one does this look like it's going to be? For me, because we've got all these parallel lines and these alternate angles and blah, 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 it's definitely going to be opposite angles. Two pairs of opposite angles equal. Check this out. In the triangle as it sits now, yeah, so this here is equal to that there, is it not? Because of corresponding angles, true? So that's great. And look, do you see that the opposite angles are the same there? You see that? So that's cool. Now if we can just try and get that this is equal to that, then we've got two pairs of opposite angles equal, therefore it's apart. Can we do that? Well, we've already got, do you see the Z here? Let me do it in a pink. Do you see the Z here? You see that? That's also a blue dot. So, because of alternate angles. And look here. What do you know about that there and that there? That's again alternate. So, that angle there is equal to that angle there. So, that DEFB is definitely a parallelogram because two pairs of opposites are equal. And I'm not going to go and write it down, I don't have space here, but you can see it and you guys can write that down. The main thing that I wanted to do was just to do a few more midpoint theorem, a few more writers that specifically had midpoint theorem in them, just so that you can get a better feel for it. Okay, I'm going to put a couple of examples for you guys to do as well on your own if you want. Yeah, so actually a very, very, very simple rule. Okay, good luck, guys.